Welcome back in, students. In this video, we are going to cover Unit 1, Lesson 5. We're going to explore rational exponents. Let me just scoot everything up a little bit. There we go. All right, so we're on page 27. So benchmark, extend previous understanding of the laws of exponents to include rational exponents. Apply the law of exponents to evaluate numerical expressions and generate equivalent numerical expressions involving rational exponents. Your learning targets, you're going to apply the laws of exponents to rational exponents, and you're going to convert between expressions involving rational exponents and expressions involving radicals. Excuse me. Okay, so warm up. Again, page 27. Just you see it down here, 27. Okay. All right, bell work. So, excuse me. Sorry. 1 second. Take a little drink. Excuse me. Okay. So use the law of exponents to rewrite the expression. Then we're going to find the value. Down here, this number is huge. So we're just going to, I really want to know that you guys know how to do the value, the equivalent expression. All right, so when we got the base is the same, we're going to add the exponent. So -5 and a +3 is going to make this x to the -2. And when you have a negative exponent, you take the reciprocal, so we flip it. So it's going to be 1/8 squared, which is 1/64. Over here, we got 3 to the 4th power raised to the 6th power. So whenever you have a parenthesis in between, you multiply those. So that's going to be 3 to the 4 times 6. 4 times 6 is 24. So 3 to the 24th power, and that is a huge number. We're not going to write all that. I just want to know that you know how to do, that part. All right, 2 11ths to, we're going to cube that. So the way it works is the cube goes with both. So it's 3 cubed over 11 cubed. 3 cubed is 8. 11 cubed is 1,331. All right, and over here, we've got 12 over 36 to the -4th power. And actually, we're going to just reduce the fraction is how we're going to handle this. So we flip this, so you end up with 36 over 12. This was the -4th power, so it's 36 to the 4th, 12 to the 4th. Those reduce. 12 goes into 12 one time. It goes into 36 three times. So you'd end up with basically 3 over 4. 1 over 4 is just 1. I mean, 1 to the 4th power is 1. 3 to the 4th power, so 3 times 3 is 9, times 3 is 27, times 3 is 81. So you'd end up, basically, it'd be 81 after all that. Forgot to tell you guys in class earlier to reduce down. Okay, flip it over. Let's see, like this. Again. Oops. Sorry, got stuff in the way over here. Give me 1 second. Okay. Let's back our camera up here. There we go. All right, over here. Page 28, 1.5.2, rational expressions. So fill in the blank with the value of each. All right, so anything raised to a 0 power is automatically 1. And anything raised to the 1st power is automatically the number that goes with it. So here, 16 to the 0 power is 1, and 16 to the 1st power is 16. Using the values above, guess what the value of 16 to the 1/2. If you type that in your calculator, it's going to give you 4, and it's because, so the top number, so it'd be 16 to the 1st, which we don't write 1 because it's understood, and that would go under the house, and the 2 outside, which we don't write the 2 either because it's square root. So it's the square root of 16, and the square root of 16 is 4. You explain the strategy. So like I said, the top number, so numerator is the exponent for the base, where the denominator, is the exponent that goes on the outside of the house, or the square root. Excuse me. So find the value of 16 to the 1/2 exponent using a calculator. Let me show you. So, oops. All right, clear. So you got 16. And on this one, this is the button to do exponent. We're going to put it in parentheses because if you do without the parentheses, it's going to do 16 to the first power, and then it's dividing that by 2, which is 8. That's not the answer for this. See, the 1/2 power is 4. So it's 1/6, this button, parenthesis, 1 divided by 2, in parenthesis, equals, and the answer is 4. All right, discuss with your partner. What do you notice about the relationship between 16 and 16 to the 1/2 power? So 16 by itself is 16 to the first power, which is 16. 16 to the 1/2 power is the square root of 16, which is 4. Oops. Okay. All right, other side here. So predict the value of 49 to the 1/2 power. Check by using your calculator. So remember, when it's half like that, it's going to be the square root. Square root of 49 is 7. Let me show you, though, just in case you don't believe me. 49, parentheses, 1 divided by 2, 7. All right, so predict the value of 100 to the 1/2 power. So square root of 100 is 10. Again, I'll check it for you. 10, 1 divided by 2. Wait a minute, not 10. It's 100, sorry. See, there you go. All right, write an expression equivalent to a to the 1/2 power. So that's just the square root of a, because it's a to the first power in the box to the square root, which you just write the box. Check your answer with your partner. You don't have, we don't update it because I know I'm right. All right, predict the value of 8 to the 1/3 power. So this is going to be the cube root of 8. So you can do, there may be a cube root button, but so here, I want you to notice, you may not be able to see it, but above the little arrow, there's a square root. So we're going to go 8, then the second button, see, it made it a square root. And we're going to move our arrow. See where that X is? We're putting a 3. Oh, good grief. Let's see if this will do right. No, it didn't. Hold on. Or 8 to the divided by 3. So 2 times 2 is 4, times 2 is 8. So 2 is the cube root of 8. All right, so this is the next one is predict the value of 125 to the 1/3 power. So that's the cube root of 125, which I happen to know is 5, because 5 times 5 is 25, and that 25 times 5 gives you 125. All right, scooching up. Write an expression equivalent to a to the 1/3. Now, that's just going to be the cube root of a, because the 1 goes with the a inside the box, and the 3 goes on the outside. Check with your partner. We've got the answer right, so we don't have to check. Flip over to page 29 now. 1.5.3. Excuse me. Use the product of powers law. So a to the m times a to the n equals a to the m plus n, because the base is the same. We're just adding these guys. All right, so 6 to the 1/2 times 6 to the 1/2. So 1/2 plus 1/2. Well, it's probably like this, not that. Excuse me. 1/2 and 1/2 equals 1. 6 to the first power, or anything to the first power, is the base number, or 6 in this case. 2 is the whole number that completes the equation. So the square root of 6 times the square root of 6 is 6. Now let me show you on the calculator. So go. That's fine. And 6 times 6. Yeah, it doesn't like that. Well, anytime you multiply a square root, if it's the same number, what you got, so square root of 6 times the square root of 6 equals the square root of 36, and the square root of 36 is 6. So it always is going to match that number in the middle. You can just Just like here, 6 to the 1/2 and 6 to the 1/2 is going to be 6 to the first power, or it's also 6. And then 6 to the 1/2 is just going to be the square root of 6 because the 1 goes inside and the 2's out there, and those are understood because that's invisible math. All right, number 3, we're going to use it for this time. We have a third and a third and a third. Well, 1/3 plus 1/3 plus 1/3 equals 1, right? 1/3 plus 1/3 plus 1/3. That's the 5 to the first power. Anything to the first is that base number, or 5. Second. Okay, sorry about that. Got a little sidetracked. All right, now, so just like we did square root times square root, well, cube root times cube root times cube root, because it's all going to equal when you do 3 of them and there's 3 on the outside, that gives you the number in the box. The cube root of 5 times the cube root of 5 times the cube root of 5 is 5. So because 1/3, 1/3, and 1/3 give you 5 to the first power, or 5, and cube root, cube root, cube root give you 5, then 5 to the 1/3 is going to be equivalent to cube root of 5. Okay, let's look up here. We're still on page 29. Number 5, rewrite each exponential expression as a radical expression, then evaluate each expression. So again, to the half, that's going to make square root of 81. The square root of 81 is 9. Just in case, you guys don't believe me. Square root of 81 is 9. Now this is going to be the cube root of 8 because we've got the 3 on the bottom, so it goes here, and the 1 is understood on the inside. 2 times 2 is 4 times 2 is 8, so your value is 2. And this is the cube root of negative 216. And that's going to be, so we'll go, I don't know how to do it on here, so we're just going to do this. We'll go, just say to the third because that's what it is. You see you get negative 6 because negative 6 times negative 6 is 36. 36 times negative 6 is negative 216. So we had to do negative here because we're doing it by an odd number, or by 3. All right, flip over to page 30. We got 30, 31. Let's see what else. Yeah, 30, 31, and then there's a exit ticket on the back of 32 we're going to do tomorrow, so I'm not going to include that in this video. But we'll go up to we'll do pages 30 and 31 first. Excuse me, sorry about all the sniffling. I'm just congested. It's going around. All right, page 30. Rewriting exponential expressions as radical expressions does not only apply to square roots and cube roots, other roots apply the same principles. So you see we're going bigger than 3. Complete the table to explore other rational exponents. So 81 to the 1/4, that's going to put you the 4th root of 81. So 3 times 3 is 9, times 3 is 27, times 3 is 81. So 3 to the 4th power is 81. See, they wrote it here, so we take it over here and say 256 to the 1/4 power. And this calculator, hold on, give me just a second. So we should say, let's do this, 4, 256. There we go. We put the number, then we do the root. So the 4th root of 256 is 4. 4 times 4 is 16. Times 4 is 64. 64 times 4 gives you 256. This is negative 32 to the 1/5. And let's just do that on here. So we would do 5 root negative 32, negative 2. Negative 2 times negative 2 is 4, times negative 2 is negative 8, times negative 2 is positive 16, times negative 2 is negative 32. And then the bottom we got 1 billion to the 1 over 9 power. So what you got is 1 billion, and we're trying to get the 9 root. Well, you got 9 zeros here, so 10 times that is going to make, but let me just prove it to you. So 9 root, and we can't fit it, I don't think. 3, 4, 5, 6, 7. Yeah, okay, let's see. Fine. Let's try that. 10. There you go. So multiply 10 times 10 9 times, and you'll get 1 billion. It's 10 to the 9th root. All right, still on page 30. I got some notes here and some problems. So 1.5.5, guided instruction, exponent laws with rational exponents. So Kalini's teacher asked her to rewrite 100 to the 1/2 power raised to the 3rd power. So you multiply these. Equivalent expression. So what law of exponents? So this is a power raised to a power, so it's power of a power. And so this would be, it's the same as 100. This is what this looks like. Well, no, that's not what that looks like. Sorry, you would add those. We're not adding, we're multiplying. So you're multiplying 1/2 and 3. So clear 1.5 times 3. That's 4.5. So it'd be 10. I mean, 100 to the 4.5, or 100 squared, which is 10,000. Okay, number 2. So expression we've got, this is multiplying, so we're adding these. So 1/3 and 5/3 is going to make 27. That's going to be to the 6/3. Well, 6/3 reduces to 2, right? And this was this is power. I think it's products of power, not power and products. Yeah, products of power, because power of products would be if we raised it. So, and check your answer and evaluate it, and we're already right. So, or evaluate the, so 27 squared. Whoops. So 27 squared, 729. Now let's just check it, okay? So we added these. So 1/3 and 5/3 makes 6/3, right? So we're going to go 27 to the 6 divided by 3 power, which is also 729. So just to check our stuff, because you never know. All right, let's flip over. This will be the last page of this particular lesson. So again, we're on page 31. Number 3. Mako explained his work for rewriting the following expression. So he's got 16 to the negative 8 seconds times 16 to the 1/2. So you're going to add these. You're going to end up with, so that's essentially 4 minus 1/2, which, let's see what they did here. So he multiplied them. So yeah, so this would be like 16 negative 8 halves, 16 1/2. So it's, so that's negative 7 halves. So you end up with 16 to negative 7 halves. So we flip it. So it's 1 over 16 to the 2 over 7. Let me see. Well, it's actually -4 minus a half, which is -3.5. So let's see. Hold on. Let's just see what the old calculator says. 16 to the -7 divided by 2. So 0.00006. So this is 1, 2, 3, 4. All right, let's see if we get the same when I do this. So 1 divided by 16 to the, so we said -3.5. So that's, yeah. Well, we'll just go 2/7, right? All right. So we're not right there. Let me see here. Yeah, he multiplied those. We wouldn't do that. Let's see. Hang on one second. Pause this just a second. Okay, sorry about that. So yeah, what it ends up being, so you've got -8/2, which is -4, plus 1/2, so it's -3.5. So it ends up being, it's 16 to the -3.5, which ends up being, instead of doing all this, and when you do that, you get the 0.0000061, blah blah blah. That was the right answer. I don't know, the flipping it and doing that, I went a little too far. We don't need to do all that. We just need to add them, and we got -3.5. And when you do that, so 16 to the -3, whoops, 3.5. See that 0.00061. So that was right. We just took us a little too far there. My apologies. Okay, try it on page 31. You guys are going to do this. We're going to go over this tomorrow in class, and we're going to start with this, the wrap up, so you guys kind of have a little preview. If you have any questions, let me know. Send me a message on Parent Square, or email me, or comment to the video. Until next time, have a good night. Please consider liking and subscribing. If parents or students, if you haven't subscribed, go ahead and subscribe. You'll get a notification when I post a new video. You don't have to wait for me to tell you. So, till next time, we'll see you.